guys, Tech Rally here and welcome to the 5th lesson of learning Vue. Today we're going to be discussing the computed property. The computed property is similar to methods, and in certain instances it can be very hard to differentiate when to pick one solution over the other. A very important difference between computed and methods is that computed properties are cached based on their reactive dependencies. In other words, a computed property function will only run when the data that it's dependent on changes. Unlike computed, methods always run the function whenever an update or a re-render occurs. Methods can get very expensive when looping over datasets and performing complicated computations. In cases like this, we probably want to take the computed approach. Before we start on an example, I want to show you what we're going to be building. What we're building is a small demo of a restaurant review app. Similar to Yelp star ratings, the app will show the user the name of the store and its star rating. The user can sort the stores by its name and lowest to highest star rating. The user will have the ability to reduce the list rendered based on the search input. Looking at the application, filtering the list based on button click would be a good candidate for methods. Searching for the store via the input would be ideal to use for computed. The rule of thumb is to use methods when you need to react to some events happening on DOM, like the onClick, and computed is ideal when you need to compose new data from the existing data source. In our case, the new data would be the filtering of our list based on the search input. For now, let's work on the 3 buttons using methods, and then we could transition into the search using computed. Similar to before, we're going to have an app.js and an index.html. Let's create our new Vue instance. We'll set the L to our root element like before, app Vue. And then we'll have a data function which returns us a data. I'll just copy and paste what we're going to be using for our data and explain further after this. And then we'll do a little bit of sorting here. Cool. So what this is representing right now is that the stores is representing the list of stores with their names and stars, and the columns are representing the column header tables for the name and the stars. And when we actually do the coding itself in the index.html, you'll be able to notice why it's beneficial to have the columns predefined in the data set itself. Let's go back to our index.html and we render the list of stores in a table format. So first we could create a table here, table tag here, and then we'll just give it a class of table. And then we could use a t-head tag for the header wrapper. And in the header wrapper, we have rows. And in the rows, we could define each column in the row as well. So for this case, we're going to do th. And in the th, we could actually loop over our columns here. So column in columns. And then right here, it'll be column. So what this column variable is the single entity that exists in app.js, so it'll be name, and then the next one will be stars. Following the header tags for the table, we need the body. So we do tBody. And just like before, we have a table row, and then a td. And similarly, we could do a v4 here, store in stores, which is going to be looping over the stores for every row. And inside of the td tag, we want to actually loop over the columns. So column in columns. And what's being rendered on each column will be the specific element. In this case, it'll be the name and then the stars. The name and then the stars. So if we were to do it that way, it would be the store object. And then here it would be the column. So as it's looping over the specific table row right here, each table row will have 2 columns. The first column will be the name, and then it will be the star rating. Cool. As you can tell, the rendered data is showing Chipotle, stars of 5, Pizza Hut, stars of 3.5. Now let's start adding buttons and start using methods. Before we start adding buttons, I'm going to use Bootstrap's class container to keep the web page a little bit more compact. Awesome. And then I'm going to copy and paste here that information here. So if we look at the code now, the table is a little bit more compact and constricted within the center. Awesome. Now let's move on to adding the buttons as well. So in here, let's just add a div container here where we'll store all our buttons. So we'll just say button container. And here let's just add 3 buttons. Button. And the first button will be store name. Second button will be lowest stars. And then the third button will be highest stars. And just above the top button, let's just add something to just give to the user, to let the user know what exactly what we're going to be changing. So we could say something like sort stores by. And if we save that, then we're going to have 3 buttons with store name, lowest stars, and highest stars. We can add some Bootstrap Css to make this a little bit more prettier. So we could just say button primary. And then here, let's do something like but class equals button warning. And then here, let's do something like class equals button warning again. If we go back to our view, we notice that basically we could say sort stores by and then sort name, lowest stars, and highest stars. Right now, these buttons aren't actually doing anything because we haven't attached any v-on click directives. Let's work on that. So if we go to the first store name, we could just say add click equals sort name. The second one, we could do add click equals sort lowest. And then the last one, we could say add click equals sort highest. Just letting you know right off the bat, we obviously haven't made any of these methods functions. So if we were to click these buttons, nothing would actually happen. If anything, it would probably error saying that these functions aren't defined. So let's actually go back to our app.js and define what those functions are actually going to do. In our app.js, we need to actually add a methods key again, like before. And then we'll create 3 separate functions to sort it properly. So we'll just first call it sort name. And then second will be sort lowest. And then the last one will be sort highest. So let's work on the first one. The sort lowest is going to take the list of stores and sort it by the name. And I'll reference you to the link of how sorting actually works, but it's pretty much boilerplate on how we want to do sorting. So I'm just going to write it out and explain it to you after I write it. So this.stores.sort a comma b. If a.name is greater than b.name, then we're going to do 1 to -1. Awesome. So in the sort name function, you're looping over the stores array, and if the first argument is greater than the second argument, the 1 indicates that it's going to be placed after the second one. If it's a -1, then it's going to be placed before. If you're a little confused on how this tertiary operator works, I could add some documentation below, but essentially if the value is true, then it's going to be 1. If the value is false, then it's going to be set to -1. We can use the same logic that we use for sort name to sort lowest and sort highest, but instead of comparing it by the name, we're going to be comparing it by the star ratings. So we could say this.stores.sort a comma b, and they say if a.stars is greater than b.stars, then we could just do 1 or -1. And likewise here, we're going to do this.stores.sort a comma b, and if a.stars is less than b.stars, then we're going to do 1 comma -1 here. Cool. Now let's go back to our index.html. Now we have our list. Let's just refresh the page. And then if we sort by name, everything's getting sorted by their names. If we sort by lowest stars, it's going to be going from lowest stars to highest stars. And if we sort by highest stars, then it's going to go from high to low. Awesome. Now that we've used methods to handle DOM event clicks, let's use Computed to handle the search input filter. In our app.js, let's create a variable called search text and initialize it with an empty string. We'll use this data variable to do our two-way data binding between our input field and our app.js search text variable. So going back to our inputs index.html here, let's create another container below this one here, and we'll do something like this. And then we'll give it an h4 here and say something along the lines of search stores by text. And then here, let's add an input field and then type text, and then we'll do a v model of the, what was the variable called again? Search text. So going back here, search text. Sweet. At this point, based on what we know so far, I think our natural tendency would be to add some kind of v-on directive to the input and then call a method. But instead of doing it that way, let's try to use the computer route to solve this problem. So instead of adding any more functionality to this input, let's do some slight modifications onto the v-for loop in the table row. So in here, let's call it something like search stores. And you're going to be asking yourself, what is search stores? It hasn't really been defined anywhere in our code yet, but we could define it in our Vue instance via the computed key. And inside of the computed object will be our searched stores. And here's where we're going to be doing our filtering based on the user input. So let's do this const filter equals new regex p this dot search text I here. So what this is doing is creating a filter variable based on the regular expression. This dot search text would be the user input data on that input field, and then I is representing a case insensitive matching. And with this case insensitive filter matching, we could actually return this dot stores dot filter, and then we take in the elements of each item in the array, and then we could do a matching based on that filter. Cool. I realized I made a typo and I used search stores instead of the searched stores, so I'm going to modify this really quickly to search stores. And if I look at the code below, now if I type in something like Carl's Jr., it gives me that. If I start with the M, it gives me McDonald's. And likewise, you can still rate everything by their lowest and highest stars, by the name. And then if we start typing in something like W, it'll give me Wendy's and Whataburger. As you can see in the code base, previously we were doing a lot of if you do this, then call this function. If you click on this, then perform this other function. But what's really different about Computed is that it's more used as a property as opposed to a function that reacts to certain DOM event listeners. If anything, the search store is just representing a reactive function that only runs when the original data set changes. In our case, the data set would be the stores. When a user is clicking and changing little things here and there based on the methods, the computed functions will still run, but whenever a person is typing different inputs, it's just doing the filtering on its own. In other words, it's being cached. In summary, this table represents the differences between using computed and methods. Computed only runs when dependency has changed, but methods will always run whenever an update occurs. The computed property is cached, but the methods are not. Computed is used as a property and not necessarily data, and methods more along the lines run based on v-on or at, but it's not necessarily required. And by default, computeds are getters, but methods are getters and setters. I hope you enjoyed this lesson. For the next lesson, we're going to be talking about making API end requests via get and